Alright, here we are with Unit 11, Lesson 7, and in this lesson we're going to be looking at something called isomers. This is definitely a vocabulary term that you should know. Here's the definition. I think it's probably easier to show you the examples of isomers, and I think that that will make it a little bit more clear as to what actually isomers are. Isomers are compounds that have the same molecular formula, and the molecular formula simply means, how many carbons and how many hydrogens there are, but they have a different structural formula. So they have the same number of, let's say, carbons and hydrogens, but the carbons and hydrogens are arranged differently. In general, a compound has to contain at least 4 carbons in it in order for it to have any isomers. And the more carbons that a hydrocarbon has, or any compound for that matter, the more possible isomers you can get. Well, how do you actually make isomers of a compound? Well, there's really 3 ways to do that. If you have a compound and you want to see how many isomers you can make, there's one thing you can do is to make a branch, and we're going to go through and show you how to do this. The other thing you can do is if it already has a branch, for example, if you have a branched alkane, to make it an isomer, all you can simply do is move the branch to another carbon. Another thing you could do is if you have an alkene or an alkyne to make an isomer is to move either the double or triple bond between 2 different carbon atoms. And I'm going to show you how to do this in a second. If you look at the examples that are right here at the bottom, the compound pentane is an alkane, and it is C5H12 would be its molecular formula. Now the simplest would be normal pentane, which is just 5 carbons and then the 10, 12 hydrogens around it, keeping in mind that every carbon has to have 4 bonds around it. In this above, one of the things you could do to make a isomer of pentane is to take a carbon that's at the end and move it somewhere in the middle to make it a branch. So what we're going to do is we're going to take, let's say, for example, this carbon, right? So we'll get rid of this carbon. We'll get rid of this carbon here, and we're going to move it to here. Right here. Okay? So if you look at it, it would basically be this compound right here. So what you do is you take, for example, the pentane, you take one of the carbons, they call it a terminal carbon, it's a carbon at the end, move it into the middle somewhere. So let me just quickly run through that one more time. What we're going to do is we are going to take this whole thing, we're going to break it off, and we're going to put it here. So we're going to take this hydrogen and attach it. Once we remove this, we're going to take this hydrogen and attach it here, and we're going to move this here. And what that will end up forming is this compound here. You might say, well, that's not an isomer, it's a completely different compound. It is a completely different compound. However, if you count the number of carbons and hydrogens, it's still going to be C5H12. So now we have an isomer of pentane. Same number of carbons and hydrogens, same molecular formula, but their structures are different. And you can even see the structures are different. You can tell that by the name. This is pentane. This is no longer pentane, it's now 2-methylbutane, right? The parent chain, if you remember from the previous lessons, now is 4, that's the butane. And 2-methyl means that you have a methyl group on the second carbon. This would be the first carbon, the second carbon. Now, another thing that we can do is we can move another branch. We can then take this branch, or this carbon and hydrogen, and move it on the opposite end of this branch and put it here. That would give you this compound here. Again, you're going to notice it is C5H12. And if you look at the name, notice that now the longest continuous chain, whether I go up this way or across, is a propane. That's this part of it. And I have a methyl group. I have 2 methyl groups. They're both on the second carbon, no matter what direction. So this would be 2,2-dimethyl propane. So these are the isomers of pentane. It has 3 isomers: normal pentane, 2-methylbutane, and 2,2-dimethyl propane. Okay, let's see if we can, if I have room here somewhere, let's do this here. Let's look at for example, the isomers of butane. Butane is C4 H10. Normal butane would be 1, 2, 3, 4, and then you put the H's around, which I'm not going to do. This is a C. This would be normal butane, N-butane if you want. Now there's only one thing that we can do to make this an isomer. We're going to take one of these C's on the end and move it into the middle. It doesn't matter if we move it here or here, and we're going to end up with this compound. I'm just going to make this one longer so the H's do not run into each other. Okay, so now this would be 2-methyl propane. There's only two isomers of butane. Normal butane, which you can call N-butane, and then 2-methyl propane. So butane has 2 isomers, pentane has 5 isomers, and again you can see the more carbons you have, the more possible arrangements that you can have. Let's take a look at a more complicated example. And again, if you can figure out the first 2 examples I gave you, you should be okay. Here are the isomers of pentene. Pentene is a 5-carbon chain, but it has a double bond. So the easiest thing to do would be to move the double bond. You can have it between the first and the second. So this would be simply 1-pentene, because the double bond is between the first and second. This would be 2-pentene. Oops. This would be 2-pentene. Okay. Now this one here, notice the double bond is between the first and the second. So that would be 1-butene. But now you have to indicate that there is a methyl group on the second carbon. So this would be 2-methyl-1-butene. This would be 3-methyl-1-butene. And this would be 2-methyl-2-butene. Okay. Now, if you look at the bottom, you're going to notice that there are, looking at the aromatic hydrocarbons. Aromatic hydrocarbons are not really something that you need to worry about. They don't ask about it on the Regents exam anymore, and even when they did, the only one they used to give you or ask about was this one here. A lot of aromatic hydrocarbons, like for example benzene, are what we call carcinogens. Carcinogens are things or chemicals that can cause cancer. So they are strictly regulated. We're not really allowed to use any of those kinds of substances actually in class. And that is it for this lesson.